In the last section, we looked at how to navigate using VOR. In this section, you will be introduced to the Automatic Direction Finder, which is referred to as ADF. Several ground facilities transmit signals that can be received by your airborne ADF equipment. The most common facility is called a non-directional radio beacon, or NDB. Certain commercial broadcast stations can also be received, but they should not be used as your primary source of navigation. NDB signals are transmitted in the low to medium frequency range and travel as ground waves and sky waves. Ground waves are capable of following the curvature of the Earth, while sky waves bounce off the ionosphere and can be received over great distances and at low altitudes. These signals are picked up by the ADF antenna on your airplane and relayed to the ADF receiver. This receiver has an on-off volume control knob, a station frequency selector, and several mode selectors. These selectors allow you to perform a number of functions. For example, the mode selector labeled ADF allows you to operate in either ADF or ANT, which stands for the antenna function. This mode provides maximum sensitivity to radio signals for tuning and identifying the station. With the selector in this mode, enter the NDB frequency in the receiver. You can find station information next to the NDB symbol on an aeronautical chart. The station name, frequency, and Morse code identifier are provided in a magenta-colored box similar to a VOR information box. With the station positively identified, place the selector in ADF. This allows the receiver to relay the information to the indicator, which displays it on either a movable or fixed card. Let's look at how to interpret the fixed card indicator. The needle on the bearing indicator will move in the direction of the station and stop when a strong signal is found. The pointer of the needle indicates the bearing to the station. In this case, it's 060. The tail of the needle indicates the bearing from the station. In this example, it's 240. 0 degrees on a fixed card is always aligned with the nose or longitudinal axis of the airplane. The needle indicates the number of degrees from the nose to the station. This angle is called the relative bearing. In this example, the relative bearing is 060. If your airplane is on a magnetic heading of north, you simply need to turn to a heading of 060 degrees to fly to the station. At the completion of the turn, the ADF will be pointing towards 0, indicating the station is directly ahead. If you're flying a magnetic heading other than north, you must add your magnetic heading to the relative bearing to find the magnetic bearing which will take you to the station. For example, let's assume your magnetic heading is 090 and your relative bearing is 060. When you add these two together, you get a magnetic bearing to the station of 150 degrees. To fly to the station, in this case, you simply turn to a heading of 150 degrees. When the turn is complete, the needle on the bearing indicator will point to 0 degrees. If you keep the needle pointed to 0, you are homing to the station. In a no-wind situation, you will fly directly to the NDB. In a crosswind, you will have to make continuous adjustments to your magnetic heading to keep the needle pointing to 0. As a result, your aircraft will travel a curved path to the station. If you want to fly a straight line, you can track a course using a technique similar to the one you used in VOR. Let's look at the procedure. Let's assume you want to track on the 240 degree bearing to the station and a right crosswind has drifted you left of course. The ADF needle will point to the station which, in this example, is 5 degrees to the right. Turn right using an appropriate intercept angle and maintain that heading. In this case, a 20-degree correction angle is being used. The ADF needle will continue to point to the station. With the aircraft heading 260 degrees, the station is located 15 degrees to the left of the nose. As you approach the course, the ADF needle will continue to move away from 0. When the deflection equals the heading correction angle, you have intercepted the desired course. Here, the ADF needle reads 340, which equals the 20-degree intercept angle. When you have turned back on the desired course, it will be necessary to establish a crab angle to compensate for wind, in this case 10 degrees. Since the airplane is crabbing to the right to maintain course, the ADF needle will indicate that the station is to the left. As you get close to the station, the needle becomes more sensitive. It's important not to chase the needle or make large corrections during this time. Station passage is indicated by a reversal of the needle. The procedure for tracking outbound is similar to the procedure used to track to the station. However, the wind correction angle is established with reference to the tail of the aircraft. Some of the techniques you learned in tracking can be used to intercept a particular magnetic bearing. To understand the intercept procedure, let's assume you want to intercept the 60-degree bearing to the station. Your first step is to turn your aircraft to a heading that parallels the course you intend to track. Then determine whether the station is left or right of your aircraft by noting the direction the ADF needle is deflected. In this example, the needle is deflected 30 degrees left. If you turn left only 30 degrees, you will fly to the station, but you will not intercept the 60-degree bearing. A good rule of thumb is to double the number of degrees the ADF needle is deflected. A 60-degree intercept angle, in this example, means you will maintain a heading of north to intercept the bearing. When the ADF needle is deflected 60 degrees to the right, which is the same as the angle of intercept, you will be on the desired track. Remember to lead your turn by a few degrees to avoid overshooting the bearing to the station. Continue to track to the station using the same procedures we discussed earlier. Until now, we have taken a look only at the fixed card ADF indicator. The only difference between a movable and a fixed card is that you can manually rotate the movable card. This allows you to place your magnetic heading under the index at the top of the indicator. In this situation, the ADF needle automatically provides you with the magnetic bearing to the station. The tail of the needle provides the magnetic bearing from the station. Sometimes, when using ADF, the signal you receive may be erroneous or unreliable. If you are familiar with some of the limitations of this instrument, you may be able to avoid or minimize errors you might encounter. For example, reception capabilities for ADF facilities can vary considerably. To be sure you're receiving reliable information, always identify the station before use, then monitor its ident feature. If your heading indicator is not properly set to the magnetic compass, you may have problems with tracking and intercepting procedures. You should monitor these instruments often to ensure that the heading indicator has not precessed. Other phenomena that may cause erroneous readings in your ADF are twilight effect, thunderstorm effect, precipitation static, shoreline effect, and terrain effect. You'll learn more about these when you read your private pilot manual and study the operator's handbook for your ADF. ADF is just one instrument in your total navigation system. In many cases, it's possible for you to navigate using ADF alone. However, it is generally used with other instruments, such as VOR. In the next program, we'll expand on the information already presented and see how it relates to advanced navigation.